Section 14.3, here we're talking about the quadratic formula, and you might write down on a sheet of paper, although this will be almost muscle memory after you've done a couple of them. But the first thing that you'll do is you'll set it equal to 0, and then we'll label A, B, and C. You might, if you don't already have this memorized, write down the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac, and then all of that over 2a. Number one, y squared minus 8y equals 1. So if we're using the quadratic formula here, first thing we want to do is set equal to 0. So that means that 1 that's on the right side, we're going to move it over. Make sure that you put that in descending order where we've got the y squared first, the y term next, and then the constant, which is the negative 1 last, and then equal to 0. So once you've got that in the correct order, you're labeling A, B, and C. And your A is just whatever's in front of y squared, which is 1. Your B is whatever's in front of y, and then your C is just that term there without a constant. So A, B, and C. Then we're plugging that into the formula. Negative b plus or minus square root of b squared minus 4 times a times c all over 2a. So I'll go ahead and do that here in red. So we've got a minus in front of b. Be careful with this. Since b is negative, you've got a minus in front of negative 8. Minus in front of b. And then plus or minus square root of b squared, so negative 8 squared minus 4 times a, which is 1, times c, which is negative 1. And then all of that, make sure this line goes under everything. So all over 2 times a. Continuing on, just simplifying this a bit, a minus in front of negative 8 is going to be positive 8, plus or minus. Negative 8 squared is 64, and then negative 4 times 1 times negative 1 is going to be positive 4. All of that over 2 times 1. Continuing on, so we've got 8 plus or minus, and then we're going to do this addition underneath the radical. So 64 plus 4 is 68. Over 2, just doing that one step there. Continuing next to it. Here, the only thing that we do next is we look to simplify this, this radical here. In some cases, if you had something like the square root of 64, you could just turn that into 8. If you had the square root of 25, you could just turn that into 5. But the square root of 68 isn't a perfect 68 is not a perfect square, so we're gonna need to look for squares inside there. So the squares are 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, and really, as long as you've got up to half of the number, half of 68, that's really as far as you need to go. So we're gonna check to see if 64 goes into each of these nicely. It doesn't go into 49. 64 divided by 36 does not come out nicely. 64 divided by 25. You can do all these with the calculator. Or not 64. Should be doing 68. (68) divided by 16. So if you're just using a calculator, 68 divided by 16 comes out to 4.25, so it doesn't come out evenly. 68 divided by 9. Make sure you're going from high to low numbers. 68 divided by 9 gives you 7.5 repeating. That doesn't work out. And then 68 divided by 4. That does come out to 17. So what we're going to do is we're going to rewrite the 68 as 4 times 17. So on the next step, we've got 8 plus or minus. Underneath the radical, we're doing 4 times 17. And then all of that over 2. And then hopefully you guys know this square root of 4 part, that's going to turn into 2. So we've got 8 plus or minus. Square root of 4 is just 2. And it's not the square root of 2, it's just 2. And then the square root of 17 has to stay inside, all over 2. And in a lot of cases, you'll be done at this point once you've simplified that radical. But if all of these numbers on the outside of the radical, if they can be reduced, the 8, the 2, and then the 2 on the bottom, you'll want to reduce if possible. And here we can reduce all of these by 2. So if you reduce 8 by 2, you get 4 plus or minus. If you reduce 2 by 2, you get 1. So we've got 1 in front of the square root of 17, so we don't need to write the 1. And then all over, if you reduce the 2 by 2, you get 1. So 1 on bottom of a fraction, we don't write. So that's it. And one thing to notice on this is that since you've got the plus or minus, this is actually 4 plus square root of 17 is one of the solutions, 4 minus square root of 17. So the plus or minus, just the sign in between, that indicates that there's 2 solutions here. So this would be one solution, this would be the other. You should be able to type that in to the computer, but make sure you do know that these are 2 real solutions. If we have an I, which we'll look at an example here in a bit, if you've got an I, an imaginary plus or minus, then you're going to have 2 non-real. Number 2, negative 9x squared minus 12x equals 4. Set equal to 0, so that 4 on the right side, we're going to move it over by subtracting it. And again, make sure you've got these in descending order. The x squared term first, the x term next, and then the constant after that. And then go ahead and label A, B, and C. So A is whatever's in front of x squared, B, whatever's in front of x, and then C. And then make sure it's not just 12 in the middle. Make sure you're including all the signs. So if it's negative, make sure your B is negative. So negative B, and again, be careful that you put a minus in front of whatever B is. And then we've got B squared minus 4 times A times C. And then all of that over 2 times A. So minus in front of negative 12 is positive 12. Negative 12 times negative 12 is positive 144. And then let's see what this comes out to. Negative 4 times negative 9 times negative 4. Negative 144. And then underneath you've got negative 18. Okay, so we've got 12 plus or minus. If you do 144 minus 144, hopefully you can do that in your head. You get 0 over negative 18. So this plus or minus 0 part here on the right, the square root of 0 is just 0. So square root of 0 we don't need. You wouldn't say 12 plus 0 or 12 minus 0. You just say 12. So here we've got just 12. We're going to forget about the plus or minus since we're not adding anything. Over negative 18. And what you'll want to do on all these ones where you have a minus on the bottom, you'll want to move the minus up. So negative 12 over 18. And make sure anytime you have fractions that you reduce them. So 12 and 18 both have a common factor of 2. So you can reduce by 2, and then make sure you reduce all the way. 6 and 9 can both reduce by 3. You could have reduced by 6 at that point, but just in case you don't, make sure you reduce it all the way. And then here we don't have a plus or minus after that, so this is actually just one solution. And it doesn't have an I or anything on it, so it's going to be a real solution. Number 3, negative 3y squared minus 6y minus 5 equals 0. So first step is always set equal to 0. It's already done, so we don't need to move anything around. We just need to label A, label B, and then label C. So we've got negative B plus or minus B squared minus 4 times A times C all over 2 times A. And then we're just simplifying from there. So negative 6 is just going to be positive 6 plus or minus. Negative 6 squared is 36. And then this is going to be negative 60 over negative 6. So we've got 6 plus or minus square root of, 36 minus 60 is going to be negative 24 all over negative 6. All right, so on this next step, I want to do a few things. Got a minus on the bottom. You can do this later on, but I'm going to go ahead and move that minus up. So on top, we'll make this a negative 6 plus or minus. And then another thing I'm going to do is, since we've got a square root with a negative inside of it, that means this is a non-real number. So we're going to go ahead and put I on the outside of that. And then the 24 becomes positive. 6 on the bottom. So move the minus up. Now it's in front of the 6 on top, and then plus or minus, we move the negative that was inside the radical outside by making it an I. And then from there, we're going to simplify this radical here. We're going to look for squares in it. If it was the square root of 25, we just make that 5i. If it was the square root of 100, we just make it 10i. But 24 is not a perfect square, so 1 squared, 2 squared, 3 squared, 4 squared. As long as you go to just about half of 24, that's probably good. So 24 divided by 16 doesn't work out nicely. 24 divided by 9. 24 divided by 4, though, gives you 6. So you can rewrite the 24 as 4 times 6. So we'll do this on the next step. We've got negative 6 plus or minus I, and then replacing the 24 inside with 4 times 6 over 6. And imagine you know the square root of 24, or square root of 4 is just 2. So I'll put that with the I, 2i square root of 6 over 6. And at this point, you'll want to reduce those if you can. The 6, the 2, and the 6, you can all reduce by 2. So we've got negative 3 now. 6 divided by 2 is 3. Plus or minus. If you reduce 2 by 2, you get 1, so 1i square root of 6, not reducing inside the radical, just outside the radical. And then on bottom, if you reduce 6 by 2, you get 3. And in some cases, that would be a good enough answer, but when there's I, you're going to split up the answer. And you'll do this if they ask for standard form. Basically, you're just going to negative 3 over 3, which is on bottom there. So you're going to divide the first term by 3, and then plus or minus. I'll put the square root of 6 over 3 with the I. We'll move the I out to the right side. So basically doing this and doing this, but moving the I to the right side. And then reducing that just a little bit, negative 3 over 3 is 1, negative 1, plus or minus square root of 6 over 3i. Be careful you don't reduce the 6 and the 3 by 3, because the 6 is actually the square root of 6. And since the bottom isn't the square root of anything, we're not going to simplify those. So this should be good enough for Hawks. And make sure you notice, since we've got a plus or minus in the middle, that this is actually two answers. 2. And if you're trying to decide whether it's 2 real or non-real, you just have to look at this I part here. If it's got an I, that means it's non-real. Number 4, I'm just going to get this one started. And there's just one little wrinkle at the beginning here. Not really anything tricky at all. But you want to set it equal to 0, so we're subtracting 8. So now we've got negative x squared minus 8 equals 0. And you'll notice here that we don't have an x term. We've got x squared and we've got a constant. So essentially you could write this as negative x squared and then plus 0x. So that's the thing I'm filling in there, equal to 0. So when you're sorting out what a is whatever goes in front of x squared. So this would be our a. And then your b is going to be whatever goes in front of x. So since there's no x term, you just put in a 0 for b. And then this would be your c. And then otherwise, it works out from there just like the other ones that we've looked at. And the last thing I want to mention is some of the examples that you see in Hawks in this section will tell you to use the discriminant at some point. And this discriminant, I should probably mention, is just the whatever you end up with inside the radical when you do the b squared minus 4ac part. That's the discriminant. But for what you guys are doing in 14.3, you can just solve it like normal, just like we've done on the previous examples, and then look at your answer, whether or not it's 2 solutions, 2 real solutions, whether it's 1 solution or 2 non-real solutions. And that's really all you'll need to actually solve those problems. They'll have a part 1 where you're technically meant to use the discriminant, but if you've solved the problem all the way out, you should be able to see how many answers you've got. And then on step 2, they're going to want you to put in those answers anyway. So you might as well just solve it like normal and determine whether it's 1, 2, or 2 non-real.